Find the coordinate of the terminal point determined by t equals pi over 6. The point we're looking for is x comma y, the coordinate x and the coordinate y determined by the number pi over 6. This is a point on the unit circle with radius 1, center at the origin. First, we need to determine the distance around the unit circle that covers the number pi over 6. We know that the circumference of the circle is 2 pi r, so the circumference of the unit circle is 2 pi times 1, which is simply 2 pi. Half of the circumference is pi, and a quarter of the circumference is therefore pi over 2. And so pi over 6 is 1/3 of pi over 2. The number t is the distance around the unit circle starting at the point 1, 0. When they get to the terminal point, we will label that point P, x, y. This distance is pi over 6. Note that if we were to take pi over 2 and divide it by 3, taking this quadrant and divide it into 3 equal parts, then each part is pi over 6. We will find the coordinate x, y using the distance formula. Recall that the distance between the 2 points x1, y1 and x2, y2 is d equals the square root of the square of the change in x, which is x2 minus x1, plus and the square of the change in y, y2 minus y1 squared. Usually in computation, to avoid working with the square root, we would square both sides of this equation, so the square of the distance is x2 minus x1 squared plus y2 minus y1 squared. But first, observe that if we were to reflect the point P about the horizontal axis and move it to the fourth quadrant, then we obtain the point Q, whose coordinate is the same x, but y is now negative. We will find the distance between P and Q. The distance between P and Q is x2 minus x1 squared plus y2 minus y1 squared, and this is the distance squared. This is 0 squared plus minus 2y squared, which is 4y squared. Notice that if we were to take the square root, we end up with 2y, as it should be, because the distance from the point P to the horizontal axis is y, and so this distance from the horizontal axis to the point Q is y, and so the distance from P to Q should be 2y. We didn't really have to compute it, but the square of the distance PQ is 4y squared. Similarly, we're going to find the distance between the point 0, 1, which is up here at pi over 2, to the point P. These two distances are the same by symmetry because going from the point P to the point 0, 1 has the same distance from the point P to the point Q. Let's call the point at the coordinates 0, 1 r, so that we can refer to it as r. The distance from P to r using the point P at the first point x1, y1 and the point r as the second point. The distance formula would give us the distance square of PR is x2, 0 minus x1, x squared plus y2, 1 minus y1, y squared. And this is x squared plus 1 minus y squared. These two distances are the same, and so we would equate the two, meaning 4y squared needs to be the same as x squared plus 1 minus y, the quantity squared. Using this equation, we will find x and y. First, the left-hand side is 4y squared, and the right-hand side is x squared plus 1 minus 2y plus y squared. This equation has two unknowns, x and y, so we can't solve for x or y at this stage, but the point P, x comma y, lies on the unit circle, and so it's satisfying the equation x squared plus y squared equals 1, and so x squared has to be 1 minus y squared. Armed with this, we do a substitution. The equation is now 4y squared equals x squared is now 1 minus y squared, plus we still have 1 minus 2y plus y squared. The minus y squared canceled out the plus y squared, so we end up with 4y squared equals 2 minus 2y, which simplifies to 2y squared equals 1 minus y. We then zero this out so that we can solve the quadratic equation. 2y squared plus y minus 1 equals 0. We can either use the quadratic formula or we can factor this. This factors nicely into 2y minus 1 times y plus 1. Let's check this. 2y times y is 2y squared. 2y times 1 is 2y. Negative 1 times y is minus y. 2y minus y is positive y. And negative 1 times 1 is negative 1. And so, using the zero product property, we have 2y minus 1 equals 0, or y plus 1 equals 0. And so y equals 1/2, or y equals negative 1. We know that y equals negative 1 is not going to be the solution because the terminal point that associates with the number t equals pi over 6 is in the first quadrant, and t equals negative 1 is in the either third or fourth quadrant. And so y has to be 1/2. If y is 1/2 and the x squared is 1 minus y squared, then plug y equals 1/2 into this equation. We have x squared equals 1 minus 1 over 4, which is 3 over 4. And so x equals the square root of 3 over 4, plus or minus. We still need to keep writing plus or minus until we justify why we drop the negative or the positive sign. This is plus or minus root 3 over 2. There are two x values here. One is root 3 over 2, and the other one is negative root 3 over 2. Again, the terminal point is in the first quadrant, and so x has to be positive root 3 over 2. The answer we're looking for, px comma y, is root 3 over 2 comma 1/2. The terminal point associated with the number pi over 6 is root 3 over 2 comma 1/2. Using symmetry, if this distance is 1 pi over 6, then another pi over 6 would give us 2 pi over 6 or pi over 3. The coordinate at this point is x is 1/2, y is root 3 over 2.